Welcome back. Quick review. In the last lecture, we talked about the concept of short term interest rate futures. In particular, we discussed T-bill futures, we talked about Eurodollar futures, talked about the quotation systems on the basis of which the quotations for these futures appear in the print and electronic media. Then we discussed the concept of discount yields and the impact of these discount yields on the hedging process. We also discussed how the settlement prices were arrived at on the basis of the relationship between the settlement prices and the quotes, the settlement prices and the discount yields. We also discussed how taking positions in the futures enables us to lock a forward rate, and by taking simultaneous positions in the spot the cash market or the cash asset and the futures in T-bills or Eurodollars enables us to lock in a spot rate with a different maturity. Today I propose to continue this discussion and move over to long term interest rate futures. In particular, I would like to talk about the T-bond futures. So far we have been talking about T-bill futures. In this talk we will discuss the nuances of T-bond futures, but before I do that, there is a very interesting concept allied to all types of hedging where futures are involved. In other words, if you hedge an exposure, a cash exposure with futures, there is a concept called tailing the hedge. The tailing the hedge involves a modification, an adjustment, a minor adjustment to the hedge ratio. The hedge ratio, as we calculated on the basis of minimization of variance, we adjust that particular hedge ratio to some extent to provide for the effect of marking to market. As a consequence of marking to market of the futures position, the cash flows occur on a daily basis. If you are in a long position in the futures and there is an increase in the futures price, money gets credited to your margin account and vice versa. Now, if there is a debit or a credit to your margin account, it entails a cost. The cost may be positive, the cost may be negative. So, we need to make an adjustment to accommodate the financing cost of the cash flows related to the margin account arising from the marking to market effect. That is called tailing the hedge. An alternative explanation of tailing the hedge can be given in terms of, if you look at this expression, which is the equilibrium price between the futures and the spot, or the forward and the spot, the forward price is nothing but the future value of the spot at the risk free rate. This implies that if there is a fluctuation, if you look at the second equation here, a fluctuation delta S in the spot prices gets emphasized, gets magnified to e to the power r t, e to the power r t is greater than 1. So, e to the power r t delta S in the futures market. So, if we talk about equilibrium pricing, the futures market or the futures prices should be or should show a magnified fluctuation compared to the fluctuation in the spot markets, and therefore, keeping all other things at par, the hedge ratio needs to be adjusted for this impact. This is another interpretation of the tailing effect which is required. Let us now look at the theory behind it. Let us assume that I need to hedge 1 unit of the cash commodity with a hedge ratio H. Then because H is the ratio of the futures position to the spot position, this implies that my exposure in the futures market will be H into QS, that is H into 1, that is H. In other words, I will have H units of the futures and 1 unit of the cash in my portfolio. And as we have discussed several times, minimizing the variance of this expression, which represents the total change, delta S is the change in the cash price of the commodity, 1 unit of the cash price of the commodity, and because we are having H units in the future market, where H is the hedge ratio, the change in the futures market is H delta F. Delta F is the change per unit, and because your exposure is H in the futures market, the change in the futures market is H delta F. When you minimize the variance of this expression, you end up with the hedge ratio of rho sigma S upon sigma F, where rho is a measure of the basis risk. Now, if we assume that the cash commodity that we are hedging and the underlying of the futures is the same, and further that rho is equal to 1, then we can express the hedge, then we can have a perfect hedge. And if in order to have a perfect hedge, if you look at this expression, the hedge ratio must turn out to be minus of delta S upon delta F, if you want a perfect hedge, which is possible if you have rho equal to 1 and this the underlying of the futures being the same as the asset being hedged, the cash asset being hedged. Now, the important assumption that we make is that the interest rates are non-stochastic. In other words, they are evolving in a predictable manner, or you can also say that they can be estimated at t equal to 0 with precision. There is no unpredictability about it, that is the underlying assumption. And let dt be the daily interest rate, that is for interest for a 1-day deposit or a 1-day borrowing, dt be the interest rate for a 1-day deposit, 1-day borrowing compounded on a daily basis, daily interest rate expressed in a daily compounded basis. And let dt be the rate applicable to a deposit from day t to day t plus 1, day t to day t plus 1. Then the future value, if you invest 1 rupee or 1 unit of money as a time t small t at the maturity of the futures, which is capital T, will be given by this expression. If you invest 1 unit of money at small t, the amount that you receive at capital T, which is the maturity of the futures contract, is given by this expression. Similarly, if you invest 1 unit of money at t equal to small t, that is today, the amount that you receive at the end of the hedge period, when the hedge is going to be lifted or closed, is given by this expression. This is at maturity of the futures, this is at maturity of the hedge. Obviously, the maturity of the hedge would normally be smaller than the maturity of the futures contract. And if you divide the two expressions, you have r of f t divided by r of h t, all the earlier terms will cancel out, and you are left with the subsequent terms after the hedge period. Whatever remains will be the compounding factor, and you get 1 plus dh plus 1 up to t minus 1, and which is nothing but r f h. If you put t equal to h here instead of this t, if you put t equal to h, then this is the expression that you get. This expression is what you get. You start with 1 plus dh, dh plus 1, dh plus 2, and you end with dt minus 1, which is precisely this expression. So, this expression holds for all t. For all t, that is important. For any value of t, this expression will hold, provided of course that t remains between 0 and h. Now, let us assume that we have a variable hedge ratio. In other words, at the beginning of each period, we set a hedge ratio applicable to that particular period. We keep on adjusting our position in the futures market such that we achieve a desired objective, which we will come to in a few minutes. But the basic thing is that we have a we do not have a passive strategy of having a hedge ratio set at t equal to 0 and that holds for the entire hedge period. Instead of that, we have a variable hedge period which we change with in this case every day. And how do we set that hedge ratio? We set that hedge ratio according to this expression. H t is equal to minus means that the positions are opposite, long is hedged by short and short is hedged by long. H t is equal to 1 upon r f t plus 1. Now, please note that we are talking about non-stochastic interest rates, therefore, r f t plus 1 would be known at time t. That is, when we are establishing this hedge ratio H t, we know the values that this particular factor is going to take, and therefore, this is a practically implementable strategy. Putting this value of RFT plus 1, this turns out to be this expression, right. Now, if I take a position at t equal to 0, if the hedge is initiated at t equal to 0, the mark to market transfer at the end of day 1 will be what? It will be the hedge ratio, because the hedge ratio represents the amount of exposure in the futures market into the change in futures price. For 1 unit, this is the change in futures price. For H0 units, which was the hedge ratio which to start with, so the total change in the futures price of my position is H0, the change per unit of futures is this much. So, the total change of my futures position will be H0 into F1 minus H0, which will be transferred to my margin account. Now, this since I will receive this money at t equal to 1 in my margin account, its future value calculated to the end of the hedge period will become H0 into F1 minus F0 into RH t, because RH1, because this is the amount that I get at t equal to 1. So, it will be reinvested from t equal to 1 up to t equal to h, that is the hedge period, and that turns out to be this amount. In other words, this particular amount will grow to this amount to the end of the hedge period. This amount grows to this amount at the end of the hedge period. Now, using this hedge ratio, what do I get? If the hedge ratio that I am going to set at H0 as per the expression that I have decided is what? H t is equal to minus 1 upon R f plus 1. So, H0 will be equal to minus 1 upon R f 1. So, substituting this value of H0 equal to minus 1 upon R f 1, I get the future value, that is the value at the maturity of the hedge of the first day's margin transfer as minus f 1 minus f 0 R h 1 upon R f 1. This factor comes from the hedge ratio, this factor comes from the reinvestment of the margin amount. We should simplify this as using that earlier expression in the previous slide. Using this expression, if I use this expression with t equal to 1, please note this expression is independent of t. So, whatever t I have here, this expression is going to be the same. So, it turns out to be minus f 1 minus h 0 into 1 upon R f h. The other terms will cancel out and I will be left with R f of h. So, that is for the first day's cash. So, what is the conclusion? The conclusion is that my first day's margin amount, its future value at the end of the hedge period will be given by this amount. Now, this process will continue throughout the life of the hedge. So, we need to sum it over the life of the hedge. So, when you sum it over the life of the hedge, we get this expression for all the margin transfers that take place over the life of the hedge. This is for the first day, then second day, third day up to the h day, which will be h minus f h minus 1 into this expression. If you add all this, the intermediate terms cancel out and you are getting this expression for the as far as the margin transfers are concerned. Now, what is this? This represents the value of my cash commodity at the end of the hedge period. So, my total payoff from the entire strategy, the entire hedge position, which comprises of 1 unit of the spot position or the cash position and this hedging strategy, is given by this whole expression. This is the margin amount, the transfers to margin at t equal to h. At the end of the hedge, this is all in the margin after all reinvestment, after everything positive and negative is reinvested. And this is the value of my cash for the 1 unit of asset that I am holding physically. This simplifies to this. This is equation, let us call it equation number 1. Now, let us look at the cash and carry relationship. What is the cash and carry relationship? The cash and carry relationship is that the futures price or the forward price is equal to the future value of the spot price. So, the forward price at any point of time t is given by the spot price S t into the future value factor, which is given by this expression. Now, this expression, please note, is over the entire life of the futures. It is not confined to the hedge period. I reiterate, it is not confined to the hedge period. If you recall, we had the expression f is equal to S e to the power R t. What is t here? T is the life of the futures, it has nothing to do with the hedge. No arbitrage when we work out, it is this t turns out to be the life of the hedge. Sorry, life of the futures, not the life of the hedge, not the life of the hedge. So, from the cost and carry relationships, using all the data that we have, the future value of S t, future value of S t will be given by the S t amount being reinvested up to the life of the futures, that is up to time t. So, that turns out to be this expression, which can be written as S t R f t. Putting t equal to, now since this is universally applicable, since this is applicable for all values of t, putting t equal to h, you get this expression, and putting t equal to 0, you get this expression. These two expressions you get for these two factors, these two quantities. F 0 is given by this expression and f h is given by this expression. Let us substitute the values there. If you substitute the values here, f 0 is given by S 0 R f 0 divided by R f h, which is here. F h is given by S h R f h divided by R f h, which cancel out. So, you are left with S h with the negative sign, which cancels against this positive sign. In other words, this S h cancels with this S h, and you are left with f 0 R f 0 divided by R f h. Now, let us go back to that relationship what we had. R f 0 upon R f h, whatever that may be, is given by R f h. R f, so what happens? R f 0 divided by R f h is given by R h 0. So, that turns out to be what? Putting this value here, we have S 0 into R h 0 as the payoff that this strategy is, this entire strategy, this entire hedged position, including the cash asset and the hedge as per this hedge ratio, this dynamic hedge ratio or this active hedge ratio turns out to be this position. Now, what is interesting here? The interesting thing is that if you look at this, S 0 is known to you and R h 0 is nothing but the future value of 1 unit of money invested at t equal to 0, that is today, inception of the hedge, at the end of the hedge period. In other words, our return equal to the return provided by these factors is guaranteed. So, you are having, in a sense, you are having a return which because these factors are taken to be non-stochastic, this return is also non-stochastic. So, by modifying this hedge ratio or by using an active hedge ratio or by using a dynamic hedge ratio, which is set at the beginning of each period, we are able to eliminate the effect of marking to market. So, this is the philosophy or the logic behind the concept called tailing the hedge. So, now we talk to take up US T-bond futures. Before we take up the T-bond futures, we need to understand the concept of price of a bond, how bonds are quoted, how bonds are priced. We had a similar situation when we talked about the T-bill futures. Different ways were there for quoting the price of the bond and different ways there for calculating the transaction and settlement prices. So, here we again readdress that problem in the context of bonds. In the context of bonds, we have two prices. One is called the clean price or the quoted price. This clean price is also called the quoted price, and then the other price is called the full price. It is the transaction price, it is also called the dirty price. So, what is the difference between the two? Now, let us take an example. Let us say there is a bond which has released a coupon payment at A, and the next coupon payment is at B, and the bond is sold. It's, you see, it's not necessary, it's not mandatory that the bond should be traded in the market only at point A or at point B. It can be traded at any time. So, let us say there is a point C at which the bond is traded. Now, when the bond is traded at the point C, the price that the bond, you see, the price that the bond will command must also cover the interest for the period A C. You see, if the bond is transferred at the point C, then the buyer of the bond is going to hold the bond throughout for the period C B. Now, at the point B, when the next coupon is released, the company is going to give the entire coupon to the buyer. Let's call him Y. The company Y is the buyer and X is the seller. So, the company is going to make the entire payment, because the bond is going to be transferred in the name of the buyer, which is Y. So, and the company pays interest, the company pays coupon to the parties whose name appear in the register, in the records. So, because Y's name appears in its records, so Y will get the entire coupon. In other words, Y will get the entire interest for the period A and B. The company will not bifurcate the interest into AC and CB and give BC to Y and AC to X. The company will not do that. The company will give the entire coupon for the period AB to Y, because Y's name by that time will appear in the register of bondholders or register of the appropriate security holders. So, that being the case, because X has held the bond for the period A to C, X must be compensated by Y for the interest that relates to the period AC. And this interest which relates to the period AC is called accrued interest. This interest is called accrued interest, ACCRUED interest. So, in other words, what I am trying to say is that when there is a transaction between two coupon dates, the buyer of the bond, in addition to the pure price of the bond, will also have to pay the interest for the period A to C, for the period for which the seller has held the bond, because Y is going to get, the buyer is going to get the entire interest, which includes the interest for the period for which the seller has held the bond. So, this is very important. This is the difference between clean and dirty price. The clean price is the bond without the accrued interest. The plain price of the bond, the pure price of the bond without any inclusion of this interest is called the clean price, and when you add the accrued interest, that is the transaction price, that is the price at which actual trade occurs, that is the flow of money that is going to take place at the point C, that is called the transaction price or dirty price, or it is also called the cash price. Now, there is one more very important point. I have explained the accrued interest. Now, let us look at an example. Let us assume that there is a there is a bond that has a face value of 1000 rupees. The coupon rate is 10%. Let us further assume that the rate of return, the market interest rates corresponding to that risk class is 12%. Now, let us say this is the last coupon that the bond is going to pay. This is the final coupon. So, it will pay the principal of 1000 rupees plus the coupon of 100 rupees. So, the cash flow is going to be 1100 rupees, and that is going to occur at this point. Let us say it is 31/12/2019. At this date, this amount of cash flow is going to occur. Now, when I price the bond, let us say, how will I price the bond? Let us say I price the bond at 1st January, that is immediately after the previous coupon was paid. Let us assume the coupons to be annual. So, let us assume that the last coupon was paid on 31/12/2018 and I am doing the pricing immediately thereafter. Then I discount this 1100 rupees for 1 year at the rate of 12% and arrive at 982 rupees. What happens if I calculate the price at 1/4, this is 1st January, this is 1/1, now I calculate the price at 1/4. Then obviously I will discount it for 9 months, because 3 months have passed, I will discount it for 9 months and the price here turns out to be 982, the price here turns out to be 1010. Why is that? Because what is happening is the cash flow that is being discounting is remaining unchanged, whereas the proximity to that cash flow has decreased. The proximity here, the distance to this cash flow was 12 months, now it has come down to 9 months. The proximity has decreased, but the cash flow remains the same. In other words, what can I say? I can say that while the amount of interest, this entire amount of interest is being discounted, entire interest is being discounted for the period, for this entire period, let us call it A B. The entire interest for the period is being discounted at A B, but the discounting is done at the point C. The discounting is done at the point C, but the interest pertains to the entire period A B. In other words, what I am saying is that the cash flow method of calculation does not eliminate, throw away the interest for the period which has passed since the last coupon payment. I reiterate, the cash flow basis, you see, you are discounting the entire coupon, but you have moved forward in time. Logically, what should have been done? Logically, only this party, whosoever is discounting at this point, should have got interest for only 9 months, but in actual fact the discounting is for the entire year. In other words, the coupon is discounted is for the entire year, but the period of discounting is only for 9 months. In other words, the interest for the period that has lapsed since the last coupon period, the correction for this is not made when we work out the cash flow pricing. So, in that sense, the cash flow pricing gives you the dirty price, it does not give you the bond price, the clean bond price, it gives you the price with embedded interest. So, the cash flow that is discounted includes the full coupon irrespective of the date of discounting, this is the important thing. Therefore, while the date of coupon payments becomes closer, the amount discounted remains the same. The coupon, the interest for the entire period is being discounted, but some period has elapsed. Correction for that amount of interest is not made. Now, how does the market price a bond? The market pricing of a bond is very similar to what I discussed just now. Very similar to what I discussed just now. This is the formula. It is obviously a cash flow formula. If you look at this, what the market does is, the market prices the bond at the next coupon payment date, including the next coupon. So, suppose the next coupon is 4 months away, then it prices the bond at t equal to 4 months. And it includes the coupon that is going to be paid at t equal to 4 months. It includes that. This is the coupon that is going to be paid at t equal to 4 months, and these are subsequent 6 monthly coupons. So, this is the in other words, what I will get here, what I will get in the square brackets is the price of the bond at t equal to 4 months, and then the market discounts it by the same factor using the 4-month discounting rate and arrives at the today's price t equal to 0 price. So, this is basically precisely what we have been talking about. They first work out the price as on the next coupon date and then discount the entire thing to t equal to 0. Obviously, these two formula are equivalent. So, a quick recap. The price calculated from the present value formula gives you the dirty price on the valuation date. Clean price is the quoted price of the bond. Dirty price is the actual cash price paid by the purchaser. Dirty price is equal to clean price plus accrued interest. Let us take a quick example. Suppose today is March 5, 2018 and the bond under consideration is an 11% bond. 11% means 5.5 semi-annually. That means it will pay 2 coupons of 5.5 at the end of 6 months, in 6 months and 12 months in 1 year. So, 11% coupon bond maturing on July 10, 2025 with a quoted price. Now, this is the quoted price, this is the clean price. Quoted price means the clean price. So, this is the price which does not include any accrued interest. This is pure price. Coupons are paid semi-annually and the first coupon, final coupon is at maturity. The most recent coupon date is January 10. So, the last coupon was on January 10 and the next coupon is July 10. The transaction is on March 5. These are the 3 critical dates. This is date A, this is date A, this is date B and this is date C. This is the previous coupon, this is the next coupon and this is the today's date. So, the days between January 10, that is the last coupon, and today's date 54. The days between January 10 and the next coupon, this is the reference period, that is 181. So, this is the total number of days in the reference period, that is 6 months roughly, but it turns out to be, because we are using actual upon 365 convention, it turns out to be 181 days and the days between this and this. So, the accrued interest will relate to this period, the period which has passed for which interest has not been paid and for which the buyer will have to compensate the seller. So, the coupon payment for this entire period is 5.50 as I mentioned earlier. So, the interest that will relate to this period which is 54 days is 54 upon 181 into 5.50, that is equal to 1.64. Now, the quoted price is 95.50, the accrued interest is 1.64, therefore, the transaction price or the cash price is 97.14. We will continue from here. Thank you.